Hey everybody, let's look at imaginary numbers today, which you might think, what in the world does that mean, imaginary number? This is a contrast, just so you'll know. A real number, we've talked about those before, a real number is any number in the world that is on a number line somewhere. It could be an integer like -5 or 20. It could be 0. It could be a rational number, which can be expressed as a ratio. In other words, a fraction like 2/5 or -8/15 or whatever. It could be an irrational number. You know, the two famous types of irrational numbers are pi, that's the one that like the decimal never repeats. And the other type is like if you have, oh, I don't know, the square root of 7. I mean, that's if it's not an integer as an answer, then the answer to that just keeps repeating and repeating as well. But those are all on the number line. I mean, the square root of 7 is on the number line somewhere. You know, 2 point something or the other. But imaginary numbers are ones that aren't on the number line, and we'll talk about why in a second. But let's look at some square root basics real quick. Let's use 4. Look at that 2 to the second power and -2 to the second power. Both are equal to 4 because what you're doing is you're squaring the negative, which is negative times a negative is a positive. This one, if you go backwards though, if somebody says to you the square root of 4, well, the answer is just 2. All right? The meanings of these two, well, the meaning of this is this. You take this, the square root of 4, which is 2. Then at the end, you add the negative to it. So the answer is -2. In other words, this is the opposite of the square root of 4. This one, plus or minus the square root of 4, is going to be +2 and -2. Those are the two answers to that. We've done those before in the equations we've solved. Okay. Well, you tell me, what's the answer to this? The square root of 3 times the square root of 3. It's the square root of 9, right? Or just 3, okay? How about the square root of 0.729 times the square root of 0.729? The answer is 0.729. Okay, it doesn't matter. As long as you got twice in there, who cares? If you got the square root of Fred times the square root of Fred, the answer, I'm telling you, is Fred, because that's how it works, okay? If you have something like this, though, this is a little weird, because look at those questions. The square root of -4. I mean, can you think of two numbers that you multiply them? In other words, one number. You multiply it by itself, it gives you -4. I mean, it doesn't exist like on the number line anywhere. Where is it? You know, you can't say -2, right? Because if you go, oh, well, I know the answer. The answer to this is -2. Well, no, it isn't, because -2 times -2 is 4, not -4. Okay, but following our rule here. In other words, if you have something twice and you multiply it, the square root of something twice times itself, the answer is the original number. Boom, 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 all the way across. Well, logically, the answer to this has to be -4. You don't have to understand why, but we figured that out as a logical progression there. So this is the actual theorem of the product of square roots, okay? This is only if the two numbers are both negative real numbers, then that is what you need to know. So make sure you know that. If you want to go ahead and write that down, that'd be good. What happens is the negative goes outside the radical sign. Okay, and we'll do a bunch of examples of that in just a few minutes. Okay, all right, so let's take a look. We know that the answer to the square root of 4 times the square root of 7, just from what we've done before, is the square root of 28, right? Okay, so if we do the square root of 4 times the square root of -7, we're just going to have to go, well, that's the square root of -28. We'll just have to stop right there for right now. But if these two, now that example fits our, our rule. Okay, that's the theorem. Okay, so this, since both of those are negative real numbers, what we're going to do is we're going to keep the 28 underneath the radical. The negative will go to the outside. Okay, we're going to use this to solve some, or just to simplify some expressions in the future. Okay, so let's do 3 of these again. Okay, you tell me, what is the answer to A? The square root of 3 times the square root of 2 is square root of 6, right? Okay. B, the square root of 3 times the square root of -2 is square root of -6, right? Okay. But the answer to this one with both of those is negatives. What's going to be underneath the radical? A 6, right? And then, dunk, there we go. Okay, that's our theorem. All right. Let's take a look at this. This is called Euler's notation. Looks like Euler's, but it's Euler's. That was his name. And that is what you want to know right there. make sure you have that. I looks like, we think of that as I for imaginary. And they've defined I as the square root of -1. So we can piddle around with a lot of numbers with this in the future. So let's take a look. 4 things you need to know about this. And we're going to do these. In fact, you know what? Let me do this on a, I'll just do it on this screen here. All right, we'll just ignore all this. We're going to go with this, okay? We're going to define that as the square root of -1. So in other words, in the future, when you see the square root of -1, or you can pull it out, you're going to call that I from here on out. And you'll use this in other math classes as well. Now, here's a question for you, okay? If I is defined as the square root of -1, logically, you don't have to know anything about this at all, just logically, you tell me, what is I squared going to be? Think about it for a second. I squared will be this times this, right? In other words, it'll be the square root of -1 times the square root of -1. We kind of already know our rule, right? So it'll be the square root of 1, right? With outside here, it'll be negative. In other words, we don't have to know that. We don't have to know that at all. We just have to go, oh, any two things under a radical we see right in a row multiplied by each other, the answer will be just that, right? So I squared is going to be -1. You need to know that, okay? You need to know these 4. I to the 3rd power, logically, okay? Again, you can figure this out yourself, okay? Look at I cubed, and then think about how it relates to I, let's call it I to the 1st power and I to the 2nd power, right? In other words, you could take I to the 1st and times it by I to the 2nd, and you would get I to the 3rd, correct? So let's multiply these together. And we'll just call this I. So I times I squared, which is -1. Well, you tell me, what is I times -1? It would just be -1i, right? And that's what we're going to call it, just -I. Okay? I to the 4th, logically, you tell me, based on what we've done so far. Based on what we've done so far, what would I to the 4th be? Now let's do this. How about we take I to the 4th would be the same thing as I squared times I squared, right? Isn't that logical? Okay, well, I squared is -1. What is -1 times -1? It's 1, right? That is your list right there. Know that list of 4. Memorize that, put it on a card somewhere, keep it, if you're still doing your notebook like this with a 51 at the top, imaginary numbers, boom, that's what you need to do, okay, because you're going to be using this. By the way, let's try something. Let's see if we can keep going. I to the 5th, based on these 2 numbers. Look at what would we multiply together to get I to the 5th? We could do either one, but we could do 2 and 3, we could do 4 and 1, whatever you want. Let's just do 4 and 1. So that's going to be 1 times I, right? The 4 times the 1 gives us the 5. The I times the 1. I to the 5th is just I. Kind of weird. Let's look at I to the 6th. I to the 6th, we could say that's I to the 4 times I to the 2, right? 4 times 2 would be 6 as far as exponents go. Okay, well that's -1 times I. -1 times 1, which would just be -1 again. Look at I to the 7. Which ones would I to the 7 be? 4 and 3, right? You could do it that way. Okay, so 4 and 3, that'll be 1 times -I. Anything times itself is just itself, right? I to the 8th would be I to the 4th times I to the 4th, right? Which means we have 1 times 1. In other words, what happens is this repeats every 4 cycles, basically. So we could just keep going. I to the 9th, 10th, 11th, and 12th, you could just keep doing it. So important to know. So because at some point you're going to see 8i to the 5th, you're going to have to break it down, and that you're just going to realize, wait a minute, there's a cycle. I to the 1st, then I to the 2nd is -1, I to the 3rd is -I, and I to the 4th is just 1. So we'll use that to solve some of these, we'll just simplify some of these. So let's look at the basic, this is the basics of what we're going to do. So let's look at the problem like this, the square root of -7. Well, What we'll do is we're going to break this up. So where it looks like, in other words, it'll have the square root of -1 in there somewhere, then we can pull it out. Okay. In other words, we'll call the square root of 7 the same thing as the square root of 7 times the square root of 1. You see how that works? 7 times 1 is -7. Okay. Well, we have defined this as I. So what we're going to say is that the answer to this is the square root of 7 times I. That's what we'll define it as. And knowing that, you can probably figure out this too. Although I think at first it's helpful to actually write this out to kind of train it into your brain. But the square root of -11 is the same thing as the square root of 11 times the square root of -1. 11 times -1. Of course, this we recognize as, by definition, I. And you would just circle that as your answer. Okay. Now this is interesting here. You can see kind of what's different about this one because 9 is a perfect square. I mean, is a square. So what we can do is we can go, okay, the square root of -9 is the same thing as the square root of 9 times the square root of -1. That makes sense? Okay. Well, we know the square root of 9 is 3, right? Okay. And this, by definition, is just I, right? Okay. So 3I. All right. Same thing here. Look at the 16. We can go, okay, that's the square root of 16 times the square root of -1. Well, this is going to be 4. This, by definition, is called I. So this is 4I. There you go. And as you can probably see, anytime you see a square root of a negative number and that number is a perfect square, you can just go ahead and not go through all this jazz. In other words, if you saw this, the square root of -36, you could just go, oh, 6I. And if you saw, oh, the square root of -100, you could just go, 10I, and so on. You can just do all those like that. Okay. And let's bust up A, B, and C here. Let's take a look. All right. Give them a whirl. Pause it and come back. We'll come back in a second. Okay. On A, you should have said the square root of 13 times the square root of -1. Which is, by definition, the square root of 13 times I. Make sure the I is kind of a little bit outside the radical because it's not really included in that. Okay, B, you probably recognize that's the square root of 4 times the square root of -1, which is 2, and then the square root of -1, and by definition, is I. Just like those previous ones on the previous page. Okay, this was C was a little bit of a tricky one, but you know, that's our old rule. It's not that bad, actually. The square root of 3 times the square root of -2, you're just going to go the square root of -6. There it is. That doesn't fit the rule about putting the negative outside here because you know, they're not both negative integers inside underneath the radical. Okay. All right. These are called complex numbers. Look at that example. Complex number, by definition, it's a terrible name. Should be like huggable numbers or something like that. That would make it more friendly seeming or something. Anyway, a complex number basically means a real number plus an imaginary number. Well, you can see that this and this, the 4 and the -2, those are real numbers. You can look at them on the number line. Yes, there they are. 6I and 3I, don't forget I is by definition the square root of -1. That's not on the number line. That's an imaginary number. That's what a complex number is. Real plus imaginary. And what you want to do is, the general accepted way to put these in order, is they say it like this, A plus BI. In other words, put the real number first, and put the coefficient, and then the imaginary number second. Okay. Okay, well this is real simple. This is just like terms. So 4 minus 2 would be 2. 6I plus 3I would be 9I, and that's it. Don't try to put these together and say 11I, no. Just like terms. All right. Here's another one. I mean, this is the same thing. The only thing you need to be careful of is that negative, making sure you have it applied, you know, distributed to both of those terms. But, you know, let's just write this a little more simply here. 4 minus 3I plus 6 minus 4I minus 2 minus a -5I, and there we go. Okay, so we have our 4, we have our 6, we have our -2, that gives us 8. -3I, -4I, it's -7I, -7I plus 5I, -2I, and there's your real number, and there's your imaginary number. That's a complex number. There you go. Okay, now here it starts looking interesting here. This is the, the kind of problems that we're going to do. But piece of cake after you remember what they are. Now, don't forget your little, I don't know, card or chart or whatever you want to call it, that I is the square root of negative 1, right? I squared is just negative 1. I to the third is negative negative I. And then I to the fourth is positive 1, okay, just by definition. So you can use that to simplify this, because all you're going to want in all these complex number simplification problems, you just want a real number, you want an imaginary number, and that's it. No I to the thirds and I to the seconds and any of that jazz at all, just i's, that's all you want. So let's take a look at this. We'll just call this 2i squared. We'll call this 3i to the third, and of course plus 2i minus 4 minus, you know what, let's just go ahead and take a step here. We'll go the square root of 4 times the square root of negative 1, which you know is I, right? So here's the square root of 4 and then I to the outside. Okay, let's go ahead and just go, the square root of 4, we know that's going to be 2. I'll just go ahead and just, write it 2 there. What the heck? Okay, minus 2i. Okay, now our job basically is to get the like terms together. We're not going to know everything yet. Let's just piddle with this first. Okay, well, let's go to, well, I squared, we look over it, and that's negative 1, right? Okay, then I to the third power is negative I. And then we can just go plus 2i minus 4 minus 2i, blah, blah, blah. Okay. All right. Well, let's keep it going here. Negative 2 plus 3i plus 2i minus 4 minus 2i. Now, if you look at that and this, those cancel. And then you have a negative 2 and a negative 4, which gives you negative 6. Then a plus 3i, excuse me, and there you go. And again, the only thing you want left on these answers is a real number and an imaginary number with I to the first power. That's all you want. No I squareds or I thirds or I fourth. They all, if you carry it on what the definition is, they take care of themselves. They just melt away and give you only I's. Okay. Here's a perfect example. So go ahead and take a second and pause if you need to. Copy this down. All right. Well, what I would do, again, if I were you, I got I is the square root of, the square root of negative 1. I squared is negative 1. I to the third is negative I. I to the fourth is 1. And just remember that and keep it with you. If you need to write it a bunch of times, do it. Okay, so let's take this and pick it apart one by one. So 3 times I to the third power, negative I. And in a couple of weeks, you'll have these down. You'll remember all of them. I squared is negative 1. Plus 7i, you can just leave that. Plus the 4, plus 2, now what's I to the 5th power? Now if you remember a couple of pages ago, these repeat, and like they just repeat. So I to the 5th is just going to be I to the 1st. It just repeats. So you can just write 2i to the 5th, just write 2i. All right. So we have negative 3i. 2 times negative 1 is negative 2. Plus 7i, plus 4, plus 2i. All right, so let's get our numbers here first. Negative 2, positive 4, that'll give you just 2, right? Okay, so we got negative 3i plus 7i, it's 4i. 4i plus 2i is 6i. And there you go, and that is your complex number. That's all there is to it. Okay, definitely helps to get that, to have a little chart or something like that so you can look back and flip back. You might even write it somewhere in the front of your notebook so you remember it all every time. But anyway, okay. All right, let's try the practice set, and we will come together. So pause it and give it a shot. Okay, so this is going to be, we'll call this 2i squared minus 7i to the third plus 2i minus 4 minus, oh dear, what is this mess? So the negative 3, we'll just call this the square root of 3 times the square root of negative 1, which means the square root of 3 times I. You probably goofed this one up, or not goofed up, or didn't quite know what to do with this one. This is kind of a weird one to start you off with anyway. So we'll just call this last term the square root of 3I, and the I goes to the outside. Let's do our numbers. You know what? Forget it. Hold on. We need to take care of these i's first. So I squared, don't forget, is -1. I to the third is going to be negative I. 2i is the same. -4, and then the square root of 3 times your I. Okay. Well, that'll be -2. That'll be positive 7i. That'll be still the same thing over here. Okay, let's get the numbers first. There's a real number. There's a real number. So you got -6. And this is where it gets weird. Okay, so obviously we can go 7i plus 2i is 9i, right? Well, 9i minus the square root of 3. In other words, like we have this many i's. 9 minus the square root of 3. Like that minus that. You know, what you can do is, and a lot of times they have this in the back of your book, is they'll go like this, like plus, and then they'll have, you know, in parentheses, 9 minus the square root of 3, and then that number of i's. Weird. Anyway, it's kind of funky when they give you for the very first problem, but anyhow, most of these will work out a little bit nicer than that. Okay, pause it and give this B a whirl here to see what you get. Okay, 3 times I to the third, don't forget that is -I. 5 times I squared means 5 times -1, plus 5i, plus 7, plus 2. Remember, I to the 5th power matches up with I to the 1st power, so that's what you'll put. So -3i minus 5 plus 5i plus 7 plus 2i. Okay, so numbers, real ones first. -5 plus 7 is 2. I got a -3i. I got a 5i. That's a 2i. 2i plus 2i is 4i. Been called that many times in my life. Okay, 2 plus 4i, that is your complex number. The real is first, the imaginary is second. Look at those, look at that group of 4. I to the first, I to the second, I to the third, I to the fourth. Memorize that as fast as you can, and that makes all these really quick ones. So, all right, y'all take care. Thank you.